Welcome, viewers. Here is an interesting question in the topic. The topic we started. So, square root of surd. Here is a surd inside a big square root. How do we solve this? The question says express this question in the form a plus b root 3. So, where a and b they are integers, or they are rational numbers. So they are rational number because it's possible we have fraction as our result, and it's possible we have it as integer. If you see it as integer is subset of a rational number, and if you see it as fraction, so fraction is still what? A rational number. So now we are expected to express this question in the form of a plus b root 3. So now let's apply the knowledge we gained from my previous class. So in my previous classes, let's apply them to solve this question. Now, look at this surd. We have square root of this, but unlike the previous example, this one is inside the root. And no, this one is a fraction. The previous example I gave was just a surd inside the root, just a surd in normal form, not fraction. But this time we have it in fraction. Now, so you can solve this question in two different ways, in so many ways. So, but let's consider this method. I think this method is even faster. How do we solve this? The first thing, when you have a surd in fraction form, you rationalize the denominator. So let's do that together. So now we want to take out what you have in the root. So after then, we use the square root. So now in the question, we have a square root of 8 plus square root of 6 divided by square root of 8 minus square root of 6. Now let's rationalize this. Don't forget, everything is still inside the root, but we want to work with this. Then later we return the square root. Now we have this. You rationalize it as a square root of 8. When you rationalize, you multiply by the conjugate of the denominator, and the conjugate of this denominator will be this sign will now change to positive. You have plus square root of 6 divided by square root of 8 plus square root of 6. Now let's simplify this further. We have product of this. Look at this numerator. They're entirely the same. So I can just write this as a square root of 8 plus square root of 6 square root of 6, everything square, since they are the same. Divided by here, when you multiply by conjugate, your result will be square of the first number minus square of the second number. Here, root 8 minus root 6. Conjugate of this number is this. So anytime you multiply a surd by its conjugate, surd are irrational number. By the time you multiply a surd, which is an irrational number, by its conjugate, it's turned to rational. What I mean by rational, in the sense that the root will disappear. And you can see from what we learn in mathematics, basic, or in algebra, you have this, you have this. The only difference is just the sign in the middle. That simply means difference of two squares. So square of the first number minus square of the second number. So now from here, now we have this simple result. Now, again, we have you can reduce this square root of 8. Square root of 8 is the same thing as 4 times 2. Square root of 2 is 4. 2 will come out. You cannot find square root of this, so it remains inside again. So you have square root of 8 equals to 2 root 2. So I will write this as 2 root 2 plus square root of 6. You cannot reduce square root of 6 again. Everything divided by, this is 8 minus 6. Now again, this becomes 2 root 2 plus square root of 6 divided by 2. But don't forget that in the question there is a big square root that covers the entire fraction. So now, meaning my real question will now be square root of this, which is now this. So now we have square root of root 8. No, sorry. Okay, let me write it this way. Square root of root 8, root 6 divided by square root of root 8 minus root 6 has now become square root of this value, which is 2 root 2 plus root 6 divided by 2. So this was so because everything here equals to this. Now, this everything here equals to this. Now, I can simplify this further, apply the, okay, sorry, there is a square. There is a square, so square. Here also square. Now, when we take the square root of what we have here, the square will remove the square root here. So now it becomes just 2 root 2 plus square root of 6 divided by square root of 2. The root of surd, you have this fraction, you have the square root, even from rule of indices. The root will affect the numerator and denominator. Square of numerator will remove the square root, so you have this only, but the square of the numerator will not change this. So that's why you have square root of 2. You take square root of, you separate the square root. Square root of numerator divided by square root of denominator. And that is how we have this. Now from here now, I can simplify this further by just rewrite this in this one. Root 2 divided by square root of 2 plus root 6 divided by square root of 2. Now what do we have again? The square root of 2 we can, according to rule of surd again, the value inside the root can divide the value inside the root. So because of that, this 2 here is 1, 2 here is 1. So square root of 1 is 1, so 2 times 1, you still have 2 here. Plus 2 here is 1, 2 here is 3, so you have just square root of 3, everything over 1. So which is this? So meaning square root of this expression equals to this.